Hello, I'm taking the exam review part 1. Bear with me, this is my first time doing this. Share. There we go. Share, okay. Excuse me. I took this the first time with my classmates, so now I'm taking it again. All right. Excuse me. Okay, so we are going to question number 1. Is this a sample or a population? So let's click here and see what the video shows.
Is this a sample or is this a population? The age of every fourth person entering the class. This is basically a sample. Why is that? The reason is because we don't count every person.
Okay, so as we could see, the answer is this is a sample, and the explanation is because we don't count every person.
Since we don't count every person, it's going to be a sample.
So I will go ahead and click on sample. Okay, on to the next question. Question number 2, sample or population. Let's click on the video.
Is this a sample or is this a population? The age of every employee at the store. It's going to be population. Why is that? Because we count each, or basically all employee age at the store.
Okay. So this would be a population because we are counting every age of each employee at the store. Okay, identify the population and the sample.
Which one is a sample and which one is a population and why? The first one says, hey, the collection of all. We have a keyword. Since we have keyword all, it means that this guy is population. The second one says, hey, the collection of 1,782 American households surveyed. Because of keyword survey, you have a sample.
Okay. So all is the keyword for population, and surveyed is the keyword for sample. So the collection of all American households is the population, and the collection of 1,782 American households surveyed is the sample. So population is the collection of all American households. Sorry, while I go back and forth, I just want to make sure I have it correct. And then the population, I believe here, is the collection of 1,782 American households surveyed. Oh, I'm sorry, that's wrong. Sample. Population is the collection of all American households. And then the sample is the collection of the American households surveyed. Yep, so double checking that. Sample survey, population all. So sample survey, population all. Okay, determine whether the numerical value is a parameter or a statistic. Let's go ahead and open up.
This question says, identify, is it a sample statistic or is it population parameter? Remember that if you have a population, the larger set, any numerical characteristic for population is population parameter. But if you're working with a sample, you're going to have sample statistic. Let's read this. It says a recent survey. We have a keyword. So since we have a survey, it means that you are working with a sample. Sample has keyword like survey, random, and so on. So when you see these keywords, it means that you're dealing with sample. A recent survey indicates that the average salary of 3,000 of its 100,000 graduate was $100,000. So it means that this $100,000 salary is sample statistic.
Okay, so that's pretty self-explanatory. Again, we are finding that keyword survey, which indicates sample. And this $100,000 salary is therefore a sample statistic. So it describes a statistic because the number 95,000 is based on a subset of the population. So let me double check real quickly. So survey, $100,000 salary is a sample statistic. And let me double check my notes real quickly because I'm a little confused on that one. I'm just confused because of the numbers, but I did write down some notes because I took this already. But yes, so it's still going to be number 2 here. It describes a statistic. Okay. On to the next one. Identify whether the statement describes inferential statistics or descriptive statistics. So let's open up the
This
YouTube.
question says, do you have descriptive statistics or inferential statistics? Question says, the average age of students in class is 25 years. So this is representing a descriptive statistic. Descriptive statistic. Why is that? Because it gives us information about the current data. If it's about future data, it means that you have inferential statistic.
Okay, so it is a descriptive statistic because it gives information about current data, keyword current data. So the average age of students in class is 25 years. So descriptive again, because it's about the current. Okay, and then determine whether the data are qualitative or quantitative.
Determine if the data are quantitative or qualitative. The colors of cars on a used car lot. Is it a qualitative data or is it a quantitative data? Remember that the qualitative data consists of attributes, labels, non-numerical entries. And quantitative data consists of numerical values or counts that you can do a little bit of algebra. Answer is going to be qualitative. Colors are all qualities, attributes.
Okay, so the answer is going to be qualitative because qualitative consists of attributes, and the colors of the automobiles are an attribute of the automobile. So therefore, I will click sorry, click qualitative. Okay, on to the next question. Determine whether the data are qualitative or quantitative. Okay, so we are doing another qualitative, quantitative.
So in previous example, we learned that the colors are qualitative or categorical data. Now, if I ask you to identify the number of complaints letter received by the United States Post Office, what is it? Is it quantitative or is it qualitative? Remember that quantitative data consists of numerical measurement. We can do algebra, meaningful algebra. So these are all quantitative or numerical data.
Okay, so quantitative or numerical. Oops, I can't see because of the ad. Oh,
Data consists.
I think I can stop it here. Okay. Quantitative because it consists of the numerical measurements, and this is giving us the number of complaint letters, so that is numerical. So we can hit quantitative and we can hit numerical for this one. Okay. So let's check out this next video to find out the class width and the class midpoint of the first class.
In this question, it was asked to use the frequency distribution to find the following. What's the class width? What's the class midpoints for the first class? And what's the class boundaries of the first class? This is the very first beam, 5252, and the frequency is 5. First of all, the class width is 3. Why is that? The difference between 50 and 53 is 3. 53 and 56 is 3. 56 and 59 is 3. 59 and 62 is 3. So the class width, the difference between the three first lower bounds of consecutive classes is 3.
Okay, so that answers the first question. The difference is 3. Oops. Because that is the difference in these numbers here. 50 and 53 is 3, 53 and 56 is 3, so on and so forth. So the class width is 3.
This is 3. You can also look at the lower bounds of each classes. Now for the midpoint, remember the definition of midpoint. The midpoint is the lower class limit plus the upper class limit divided by 2. 50 plus 52 divided by 2 gives you 51. And finally,
okay, and then we found the midpoint by, again, taking the lower class limit plus the upper class limit and dividing it by 2. So 50 and 52 divided by 2. So that gives us 51. Oh, and we can go on to the next question. Okay, so class with the greatest relative frequency has a representative midpoint of, let's open up this video.
let's take a look at the relative frequency for this histogram. As you can see, you have 1, 2, 3, 4, 5, and 6 bars, where you basically have 6 classes. Each class has a midpoint: 100, 110, 120, 130, 140, and 150. The class with the highest relative frequency is this class with midpoint 110, and it is 35%. The class with low.
So the highest frequency, the relative frequency midpoint is 110. And then the class with the least relative frequency is, I'm going to guess 150, but let's see.
Lowest relative frequency is this class here with midpoint 150.
Because it is the lowest here, and then
the relative.
so we've got the lowest and we've got the highest. So 150 is this one here. And then let's find out what the class width is.
Frequency is about 3%. So if I ask you to find the class width, I'm going to say that, hey, by definition, the class width is the distance between lower or upper limits of consecutive classes. But note that we don't have the actual value for the lower or upper classes here. What we have instead, we have the representatives, which are the midpoints. So basically, you can just find the difference between the midpoints, and that is your class width. 110 minus 100 is the same as 120 minus 100. The difference between these two midpoints, the difference between these two midpoints, 130 minus 100.
So as we can see, it's going to be 10 because that is the number differences here between the class width is a distance between, so we don't have lower or upper as explained. So we're just going to look at these bottom numbers and figure out what the distance is, and that it's going to be 10. So the class width is 10. Oh, did I skip one? Oh no. All right, so I don't need to open the video to know this. The answer for determine whether the approximate shape of the distribution in the histogram is symmetric, uniform, skewed left, skewed right, or none of these. The tail of the histogram here is going to determine how it is skewed. And since this is on the right side, it is going to be skewed right. And then again, we're looking at the tail here. The tail is on the left side, so it is skewed left. Okay, and let's see. Use the histogram below to approximate the mode heart rate of adults in the gym. Let's go ahead and open it up.
In this question, we have a histogram, and we want to know what is the measure of center here. Remember that if you have a symmetric distribution, mean, mode, and median, they are all the same, and the balancing point is going to be in the middle. So let's go back to this histogram. It seems like the middle point is.
Yeah, so this one is pretty self-explanatory. If it is symmetrical, which this graph is, then the midpoint is going to be 70. The mode is going to be 70.
The middle point is. So let's go back to the same and the balancing for here. Remember that if you have a symmetric distribution, mean.
All right. I just wanted to make sure that was correct. And moving along, use the histogram to approximate the median. Let's click on this and see.
In this question, we have a histogram, and we want to know what is the measure of center here. Remember that if you have a symmetric.
So this is going to be actually the same answer, because if it's symmetrical, which it is, the mean, median, and mode are going to be that midpoint, resulting in 70 yet again. Okay, and let's go ahead and check out this next part. Find the mean, median, and mode and sample standard deviation of the following numbers. Oop. There we go.
In this question, I ask you to find the mean, median, and mode of the data. So first of all, you're going to use your calculator. You're going to go to Stat, and then you're going to go to Edit, enter all numbers in L1, as I did before. And then you're going to go to Stat again, use arrow key to go to Calc, then select one variable statistic. In one variable statistic, since everything is in L1, you're going to select L1. Leave frequency list empty, do the calculation, and as you can see, the average X bar is 63. If you go to the next page, you see the median 64. And by looking at the data, by checking the data, you can see 65 has the highest frequency, so it is your median.
Okay, so 65 has the highest frequency. I just want to take a snapshot of this layout because that is really good for my notes to show the step-by-step breakdown of the calculator.
Frequency, so it is your median.
All right, so
let's take a look.
Like we said, like it was stated,
5 has the highest frequency.
65
so
has the highest frequency.
Median.
So it is the median. So let's go ahead and enter that. 65 is the median.
Let's take a look at our calculator. Let me show you how to use your calculator and do the calculation live as well. So let us share the screen. Here we go to stat, and then in edit, we enter every number in L1. You can use L2, L3, and so on, but make sure when you're going back to stat, calc, one variable statistic, you select the correct column. Frequency list empty, do the calculation, and as you can see, X bar, or the average, is 63. The sample standard deviation is 3.33.
Okay, so the representatives on the calculator, so
the average is 63.
Standard
the sample
deviation,
standard deviation is 3.33.
3.33. So the sample standard deviation is 3.33. And
population standard deviation is 3.16.
Oh, make sure that was standard. Yeah, sample standard.
And when you use the arrow key to go further down, you can find more information. For example, the median is
going to be
64.
Oh, I put that the median was 65. So let's see here. 3.33 is correct for that. Let's go back and look real quickly.
You can use L2, L3, and so on, but it is your median. Let's take a look at our page. You see the median 64. And by looking at the data, by checking the data, you can see 65 has the highest frequency, so it is your median.
So 64 is median. I think mode is the one. Let me check my notes real quick, because I think that was question 14. 14. Oh yeah, okay. So I think that was a mistake in the video. The mode is the one with the highest frequency, so that's 65. It was accidentally said 64, so that's where the confusion was. The median 64, and then the mean is 63. Okay. I just wanted to double check that.
Let's take a look at our calculator. Let me show.
Yeah, so the X bar. Great. Okay, and let's check out the next one here. The top 14 speeds in miles per hour for pro stock drag racing over the past 2 decades are listed above. Find the mean speed. Open that. Oh, disappeared. There we go.
In this question, I ask you to find the mean, median, and mode of the data. So first of all, you're going to use your calculator. You're going to go to stat, and then you're going to go to edit, enter all numbers in L1, as I did before. And then you're going to go to stat again, use arrow key to go to calc, then select one variable statistic. In one variable statistic, since everything is in L1, you're going to select L1. Leave frequency list empty, do the calculation, and as you can see, the average X bar is 63. If you go to the next page, you see the median 64, and by
okay, Oops.
Looking at the data, by checking the data, you can see 65 has the highest frequency, so it is your median. Let's take a look at our calculator. Let me show you how.
Oh, we're looking for the mean right now.
To
There
use
we
your
go.
calculator and do the calculation live as well. So let us share the screen. Here we go to stat, and then in edit, we enter every number in L1. You can use L2, L3, and so on, but make sure when you're going back to stat, calc, one variable statistic, you select the correct column. Frequency list empty, do the calculation, and as you can see, X bar, or the average, is 63. The sample standard deviation is 3.33. Population standard deviation is 3.16. And when you use the arrow key to go further down, you can find more information. For example, the median is 64.
And I think that pulled up that previous video. Did I pull up the wrong one?
Next question, I ask you to find the mean.
Oh no, that's the same one. Okay. So we are finding the mean. So my answer for this one when using the calculator is, oops. So finding the mean. We are going to add up all of those numbers. So the 181.1 and so on here on the screen. And then we're going to divide it by the sum total of numbers. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So the answer that I got after doing the calculation of adding those all up together and then dividing it by 14 is going to be 195.8. Okay. The numbers of runs batted in that Sammy Sosa hit in the first 15 years of his Major League Baseball career are listed below. Find the mean and median number of runs batted in. Round the mean to the nearest whole number.
In this question, you have a set of data, and the question asking you to find a mean, median, and round the mean to the nearest whole number. We're going to use our calculator to enter these numbers and do the computation. First of all, you're going to go to Stat and then go to Edit. In Edit, since we already used L1 for previous data, we're going to use L2 to enter these numerical values. Then go back to Stat, use arrow key to go to Calc, one variable statistics. In one variable statistics, instead of L1, you're going to select L2 because the new data was entered in L2. Then leave the frequency list empty, go to the calculation, and it calculates the values for you. X bar is 96.666, and if you round this, you're going to have 97 as the closest whole number or integer. If you go further down, you're going to see the median to be 103. Well, what is the mode here? What's the number with single number with repeated frequency? So here you have 13, no repeated frequency. 70 is repeated twice. 33, no. 25, no. Well, 93 only repeated once. And you have 119, which is repeated twice, the same as 70, so none of these are mode. 158 repeated once, 141 once, 138, and then 160, 108, and or 103. So as you can see, there is no single value repeating. So it doesn't have any mode. Mode doesn't exist. Let's take a look at our calculator.
Okay, so that is our answers there. So X bar, which is the mean, is rounded to the nearest decimal, 96.7. So we're gonna enter that there. The median is listed here at 103. Okay. And then the mode is a DNE, does not exist because there are no repetitive numbers, no frequent numbers, DNE. So we're gonna enter that there. Okay. And then question 17, find the mean, median, standard deviation, and range of data. Let's give it a click here.
Here you have a bunch of data. 20 data are given to you. You want to find a measure of center and measure of variability. So first of all, go to Stat, Edit, and everything in L3. We already used L1 and L2 in previous data sets. So enter everything in L3. Then go back to Stat, use arrow key to go to Calc, and one variable statistics. Make sure your data, which are in L3, also indicated in list L3. Leave frequency list empty and then do the calculation. When you do the calculation, it gives you X bar, which is the average, S sub X, which is the sample standard deviation, sigma sub X, which is your population standard deviation. You can also find the range of the data as well. So let's take a look at our calculator and do the computation with calculator. Let us share the screen with you. Very good. As usual, we go to Stat, Edit. Everything is entered in L3. Go back to Stat, Calc. I'm using my arrow key to go to Calc and then enter one variable statistics. Make sure it is L3. Again, if it's a different column, you're going to use second 3 to change it to the new column. Do the calculation. And as you can see, X bar is 70.35. S sub X is 1.7252. Sigma sub X, which is population standard deviation, 1.68. And go further down to find the rest of the data. Here you have your maximum value 74 and minimum value 67. You can do the difference between these two and find the range. 74 minus 67 is the range of the data.
Okay. So 74 minus 67 is going to be 7. And then the sample standard deviation is 1.7. So that's going to be 1.73 rounded to the nearest decimal. So the range, again, is that difference between those two numbers, and you get 7, and then the sample standard deviation is going to be 1.73 based off of the calculator. Oh, and then we are going to submit. And let me stop sharing. And that completes the exam 1 review.